everyone, welcome back to STEM for Others. Today we're going to be going over train, test, evaluate, how we're going to actually train our models, test them, and then evaluate them. Okay, so training and testing data set. So when you're training your model and testing your model, and when you want to evaluate how your algorithm works, you're going to split it up into two different subsets for your data. And usually you can do an 80-20 or a 75-25 split. The majority of the data should be going to training so the model can learn that data set and learn the actual patterns so it can do better on the testing data set, the unseen data. So we train and test algorithms we have chosen to see how well machine learning can perform on that data set. Okay, so the code for train test split is a little bit long, but it's all very important. So first you want to just import everything. So all your imports are here listed out unless you want to use another algorithm. You're going to import maybe something else, but here we're importing a logistic regression, but we're always going to import pandas, and we're always going to import train test split, and we're always going to import our metrics. As long as you want to see what your metrics are, they're really important so you can see how well your model is doing. I really recommend using confusion matrix if you're doing something like a classification where it's really easy to see what was the false and negative, the false positives and the false negatives and everything, so you can really translate your findings well. Next, you're going to split your data. So you can split it based on features. This is what it's doing here. If you have some features in your data set, X is being split into feature 1 and feature 2, but you can put in any features. And then the train test split, here is a 75-25 split. So we have defining all of our X train, X test, Y train, Y test, and then you're doing the actual split with the X and the Y. And you're always going to want to make sure that your X is capitalized and your Y is lowercase. That's just a rule across the train test split code. And then your test size is 0.25. That's what we established it as. You can change it to 0.2. You can try it multiple different times to see how it impacts your results. That would be called hyperparameter tuning. We went over that in the last section, but that's just an example. And then your random state as well. So for the model, we have our logistic regression. We're just calling upon our model here with the model fit. And then we are making our predictions so we can actually test the accuracy, how well we did versus how well we predicted. So we want to make our prediction. So that is YPRED. And then for accuracy, it's just accuracy score of the test and the prediction. And then the confusion matrix is something where you can put in the test and the prediction as well, and that will just output a nice confusion matrix for you. So switching out models, all you have to do is replace the model name. So instead of model equals the logistic regression, here we're putting in decision tree classifier. So you just set model equal to whatever model you're using, and that makes it easy so you don't have to go to every little section and put in decision tree classifier. So you can replace this with any algorithm to your data set as long as you import the correct libraries for that specific algorithm. So some algorithms have different libraries, different things that you need to import for them. So make sure that you can look at that specific algorithm up, and that code will come up for that the libraries that you need to import. So model metrics. These are ways that we can look at how well our model is actually performing. So there's many different types of metrics. I made a whole couple of slides about these metrics in the past videos, and maybe you've seen them, but this is just a little refresher, but you should probably know what these are. So accuracy tells you how many predictions were correct, how many predictions versus the test were actually right, and then precision is out of all positives of the model. Out of all positives the model predicted were positive, how many were actually positives? Like how many were truly positive? And then recall, out of all actual positives, how many did the model predict correctly? And F1 score, harmonic of precision and recall that ranges from 0 to 1. 1 is perfect and 0 is not. So these metrics will kind of work together to tell you how well your model is doing, because accuracy is good. Accuracy is what we mostly rely on, but recall and precision are also very helpful in seeing behind your accuracy how well you're actually doing from different model to model. So for coding your metrics, you want to import all your metrics. I think this was in the last slide too, but from your sklearn metrics, you can import your accuracy score, precision, recall, and F1. So then you can just establish all of these as your variables and put in the accuracy score, precision score that you imported, and then put in your tests and your predictions to output all your metrics. Okay, then let's talk about the confusion matrix. So we have true positives, true negatives, false positives, and false negatives. So these true positives, we also talked about this in the last few videos, but true positives are values that show the model correctly predicted a positive class. So to have a confusion matrix, you need a positive and a negative class. And then true negatives values would show the model correctly predicted a negative class. False positives values would show the model incorrectly predicted a positive class, and false negatives, the values would show the model incorrectly predicted a negative class. So we have a confusion matrix here. We have true positives, false negatives, false positives, and true negatives. So for coding a confusion matrix, we just want to import it from your metrics as well, and then you can just call upon it and set your variable as CM, and then we can change the CMAP to have different colors. This is a blue one, and then you can title it and give some more description if you like with other titles. And this is all for today's video. So this just went over, again, how do you split up your data set into the testing and training to actually evaluate your model, and then how can we look at it through different metrics and the code. Next video, we'll be doing a walkthrough of the code in an actual notebook to see how everything flows, how it's going, because I know these slides can sometimes be confusing when you're just placing everything in, but we're going to go through and show what it actually would look like in a true notebook. So watch that next video if you're having trouble with anything, and thank you so much.